Hello, welcome to my channel. I am Ameya and today we are going to see the beam problem in Ansys APDL. So we have created one directory, job name, and we are starting with our APDL. In the meantime, what we can do is we can check out our problem. So what do we have here is we are having a cantilever beam with a UDL and a load at the free end. The material property is given to be 200 GPa and cross section is given to be square and side is given for square is 125 mm. Okay, so we will be solving our problem in APDL. Okay, so let us start and proceed with our problem. So we will be going for preferences, structural, that is our first step. Then you can go to preprocessor, element type, add, edit, delete, add. This time we will be going with beam element. We have two elements, beam 188 and beam 189. The basic difference is in 189 you get three nodes, so one middle node is added into the 189 element. That is the basic difference which we need to understand. So we will go with two node 188. We will select it. So there is no requirement of real constants. We will go to material property, material model, structural, linear, elastic, isotropic. Okay, and in that we will be providing 2E5, that is your modulus of elasticity. 200 GPa will be converted into Newton per mm, and then 0.3 as your Poisson's ratio. Okay, then you can go to the, sorry, you can close this. Yeah, then you can go to the sections, beams, common sections. This time we have given the square section. So section ID is 1. I am giving square 1. Type you can select it from this drop down menu, and then breadth and height of the section. So we have a square section, so we are going with 125 and 125 on both B and H, and you can see OK. So one section is already added in my system. I will go to modeling, create key points in active coordinate system. Now let's see which key points we have to create. So first we have to create the 0 0, then 1 meter, that is 1000, then 2 meters, that is 3000, and 4000. Okay, so 0 0, I have 1000, apply, then you have 3000, apply, and then you have 4000. Okay, so four key points are created. We will be creating lines, lines, straight lines, first, second, and third. Okay, make sure wherever there is a UDL, you are giving a specific nodes and numbers for the endpoints of the UDL, because that will be helpful for giving the UDL in Ansys APDL. Okay, so lines are created now. So we can go to meshing. We will be doing simple meshing. So go to mesh tools, we will go to lines, and this time we will basically give attributes for all, because there is no change in cross section as such for this problem. So you can set the lines. I will set all the lines to 10 number of elements. So everything is divided into 10. The middle element is having larger length, so there will be larger elements in the middle. That is fine, no issues. You can mesh and plot multiplot. So this is how you do the meshing for the beam problem. Now about the loads. Now the loading condition in beams is very specific. Okay, so you have to understand different loading conditions. So we will be solving different conditions for in coming videos for different problems. In this video, it is given to be a cantilever beam, and what do we understand by cantilever beam is one end is completely fixed. So all degrees of freedom will be fixed. So you can go to key points. I will select this key point. Okay, all degrees of freedom fixed. Okay, then what we have a load of 2 kilonewton going downwards. We will do that first. So you have force on key points. I will select this key point, and you have Fy 2 kilonewtons. So that is 2000. We'll just verify that 2 kilonewton, and going in downward direction, that's why it is minus 2000. Say okay, and then there comes the UDL. Now in Ansys, UDL, you cannot find the UDL in the force moment, you will find UDL in pressure. Okay, so you can go to pressure, there is an option called on beams. Okay, so we will select on beams option for UDL, and you have to select the elements which you want to apply the UDL. Now here the carefully you have to select the load on which you want to on which elements you want to add that load. So I'm going to the box option here. I know I have created 10 elements in this length, so I will just create a box around that, and in count it will be showing 10 elements. That means only those elements are selected. You can say OK. Once you say OK, just a second, let me close this. Yeah, once you say OK, there is an option of load key. In this we will enter 2. Now why we enter 2? The load key 2 represents the UDL in Y direction, and in this case we are going for the Y direction. That's why we enter load key is equal to 2, and it's a UDL, so node pressure at one node and pressure at the other node, I node and J node, both will be same. Okay, so we are going with same load, but it is 4 kilonewton per meter, so Newton per meter will be 4 Newton per meter, same conversion. So we will go with 4 and 4 on both and say OK, and that will show you the UDL on the element. Okay, so these are the basic settings which we do in preprocessor for this specific problem. You can go to plot control, plot multiplot, then we can go to solution, solve, current ls. You will be solving the problem, the solution will be done. Now don't go for directly going for a result, you have to read the previous set. Okay, so go to read results, last set. This is a very important step. Unless and until you do these steps, you will not find any element type, element table and all other things. Okay, now what do we need to find now? So these are the outputs which are generally listed in your beam type of problem. So first you need to find the SFD BMD. Okay, so we will go to element table, add edit define table, add, and first you will add by sequence number SMIC. Okay, so first I will show you how do we check. So in help element you have this SMSC for moment, that is 2 and 15, and for shear force, that is 6 and 19. So we have to add 6, 19, 2 and 15 for SMSC. So we will add 6 first, then you can go to SMSC 19, apply, then you will add 5, apply, and 15. Okay, so I have added 4 tables, element tables, 6, 19 for SFD and 5, 15 for the BMD. Now, where we will find that SFD BMD, you can go to plot results, you can go to contour plot, element table, sorry, not element table, element line element represent results. In line element results, you have the J node and I node and J node. Okay, so if you check that help again, the first node is I node and second node is 19. So you have to select first as 6 and second as SMSC 19, and that will give you the SFD diagram. Okay, you can capture this. So you can just capture this image, save as, say, SFD1, and then you can use this image for your reference later. Okay, then what you have again, go to line element, you can go to 5 and 15, that will give you the BMD. So this is the BMD. Yeah, just a second. Let me just check. 2 and 15. It's not 5 and 15. I have made that mistake. So I will correct that. Don't worry. So you can go to element table, define table. I don't want this to be 5. So I will delete it and I will add one more, that is 2. 2 and 15. Close. You can go to again plot results, contour plot, line elements, and you will go with 2 and 15. Yeah. So this is what the BMD is. You can get the maximum bending moment. You can just go to plot controls, capture image, save file, BMD. Okay, now what else you need? You can go to plot results, you can go to counter plot nodal solution, you can go with the displacement solution, all displacement vector sum. Yeah, if you want to have the section on, you can always do that. So plot control, style, size and shape, section on. So this is how it is going to bend. You want to do the deform shape, you can check the deform plus undeformed, how it is deforming. Then you can go to, what else we can do? We can go to list results. Nodal solutions will give you the list of the displacement. Now we are interested in the reaction solution. And if you say all items, it will show you the reaction, that is fx, fy, fz on various elements, and what will be the moments about that. That is the reaction solution. This is also the required part for your analysis. Same way you can find the stress also. LS1, the element nodal solution, LS1 will give you the stress for the beam element. Okay, so this is how you solve the SFD BMD for the beam element in Ansys APDL. Okay, so if you like this content, do subscribe my channel, follow my channel, and share a word about channel with your friends. Thank you for joining.